So, dear students, we are going to see about some of the important topics in the digital electronics for solving for gate. And so here I have shown here the row of minterms and max terms, how the minterms and max terms are expressed in digital. So, the minterms are nothing but the sum of product terms, and here the max terms are expressed with the product of sum terms. Okay, so and also we know that min terms are always represented with small m and max terms with capital M, and you can see here for a representation of 0 0 0, the min term will be expressed as a dash b dash c dash, whereas in max term it will be represented as a plus b plus c, and this will be followed for all the combinations. And so here what is an SOP and POS is explained here. Normally is a standard form and canonical form. How we can express is that in a standard form, for example, if the standard form is expressed here like this, with an expression f of ab is equal to ab plus ab dash plus a dash b. Here we can see that all the terms, each and every term here is having the literals a and b. Here also you can see the both the literals are present here. Such an expression where all the terms, each and every term is having all the literals, is said to be an canonical form. It is said to be an canonical form. And if suppose any one of the literal is missing, so I can mention it here, like for suppose if an expression is f is equal to a dash plus ab plus b dash a. Such an expression, here we can see that this first term a dash is missing with the term b. Literal b is missing here. So such an expression is said to be a standard expression which has to be converted into canonical form. Only when we convert it into canonical form, we will be able to form the minterms. Okay, so how to convert this into canonical form, we will be seeing in the coming slides. So here again, this is a gate question. A function f of abc is defined by three boolean variables a, comma b, comma c. When expressed as sum of products is given by, they have given an expression where a bar, b bar and c bar are the complements of the respective variables. The product of some form of function f is. The question is, they have asked like this, and here we are going to form the, they have given the SOP form and they have asked the product of some form. Okay, so now we can see for whether the expression is in canonical form. Yes, it is in the canonical form. This can be equated. This can be equated with the terms that is a dash b dash c dash as 0 0 0, and this term is 0 1 0, and then this is 1 0 0, and this 0 0 0 is nothing but the equivalent to the equivalent 0. 0 1 0 is number 2 and 1 0 0 is 4. Now we can write down, this is the given expression with the minterms is f is equal to summation of minterms 0, 2 and 4. Now we know that this is in the SOP form, and they are asking to write it down in the product of sum form. In product of sum form, where we want to convert this into product of sum form, we can express it with the pi and max m terms. What are the terms that are missing here can be written down as a product of sum. So 0 is present here, so 1, 2 is there, so 3, 4, 5, 6 and 7. Okay, so totally there are 3 variables, so maximum there can be only 7. As there are 3 variables, there can be maximum 7. So these terms now I am going to express in the product of sum format. Then only we can find out the expression. So for 1, this 1 can be written as 0 0 1, this 3 can be written as 0 1 1, and 5 as 1 0 1, and 6 as 1 1 0, and 7 as 1 1 1. And max terms, how they will be represented, I have shown in the first slide. You can go and see that 0 0 1 will be represented as a plus b plus c dash, this as a plus b dash plus c dash. Then 1 0 1 is represented as a dash plus b plus c, and then 1 1 0 and 1 1 1. 1 1 0 is represented as A bar plus B bar plus C, and the last term 1 1 1 as A bar plus B bar plus C bar. Okay, so these are the equivalents of the terms whatever I have written here. So look for these terms, and then the expression is given. What is the expression we got here? A B C bar, A B bar C bar, A bar B C, A bar B bar C bar. This one is C bar. Yes, now this is correct. Okay. So next we'll go to the solving the next problem. This is asked in the gate question. For the Boolean function f of a, b, c and d, the minterms are given here. They have asked the essential prime implicants. We know that essential prime implicants are the prime implicants which form the minimized expression. Okay, so this can be formed by without any overlapping. Okay, so whenever you draw an K-map, then only you can find out the prime implicants and essential prime implicants. So we can draw it now. This is a 4 variable K-map. So and I am writing down the numbers 0 to 5 7 8 10 12 13 14 15 12 13 14 and 15. So how to group them? First of all these corners are having 1, so I can take them into a single group, and then I can look for the next group is this 4 ones, and these 4 can be taken into one single group. The expression is having A, B, C and D. So the corresponding literals are written as 0 0, 0 1, 1 1 and then 1 0. Now we can write down the expression for this. Now which one is overlapping here? We can see here these two things are overlapping. Here 4 number of ones are grouped into one group, and here these two ones are overlapped with this group also. So which one is essential? Which one is which one can be removed off? This is an essential prime implicant. I can write down the essential and prime implicants. So any other terms which can be formed, here you can see these two terms. If I am framing this term and this term, okay, now the essential prime implicants can be formed. The essential prime implicants can be written as f is equal to the 4 corners. First we'll write down for the 4 corners, these 4. So it can be written as b dash, d dash plus then the next one is the center one. We can see this one will be b d, and for the leftover terms it can be taken as AB. Okay, so this one is going to be the essential prime implicants, and this will be the answer for that. The next question is, a 3-input majority logic gate has inputs x, y and z. The output f of the gate is logic 1. If 2 or more of the inputs are logic 1, the output of f is logic 0. If 2 or more of the inputs are logic 0, which one of the following options is a Boolean expression for the output f? They have given and then a consideration, and for this requirement we have to frame the output. So first you have to draw the truth table for whatever given requirement they have given. So for x, y and z they have given. So for x, y and then z, and then for an output function f we can draw the truth table. So x by z is 3 combinations. So 2 power 3 will be totally 8 combinations will come. 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0 and 1 1 1. Now what is the first consideration? The output f of the logic gate is logic 1 if 2 or more of the inputs are logic 1. 2 or more. So on the consideration, the output is going to be 1. So 2 inputs, 2 or more inputs, the output is going to be 1. Now for the remaining, for the output is logic 0 if 2 or more of the inputs are logic 0. So here we can make it as logic 0. Now we can draw the K-map and write down the expression. So it is 3 variables. So I am drawing a 3 variable K-map for the x, y and z. 0, 0, 0, 1, 1, 1, 1, 0 and 0 and 1. So the terms for 0, 1, 1 is 1. Similarly 1, 0, 1 is 1, 1, 1, 0 and 1, 1, 1. So now we can go for grouping the terms. The terms are grouped here and the expression can be written here as f is equal to yz plus x z plus x y. Okay, this is the correct answer. Okay friends, so we will see in the next video. Thank you.